Sorry, my video kind of cut off, but I was at this point, x squared equals 8 times 2048, which you could write as 16 times 1024, which is 2 to the 10. So x should be 4 times 2 to the 5. Okay. And it says find x, so it's almost kind of telling, you're assuming that it's unique. You could certainly try, you could certainly sub this in to find y, and then see that x times y is 2048, and the thing is satisfied. Okay, so that little bit of inspiration really gets you to the answer. You know, if the check is quick, it's fine. If you didn't have a good way to check it, I mean, you'd have a really good reason to put this as your answer and move on until you had some extra time to come back to it. Okay, so keep going. So next one I want to try and do is question 5. 1 over a plus 1 over b equals 1 over 20. A and b are positive integers. Find the largest value of a plus b. Okay, so if 1 on a plus 1 on b is 20, 1 on 20, then you could see straight away that you know, a and b both being 40 works. And so the sum would give you 80. Okay, but that's not so big. So you might wonder if it is the biggest a plus b possible. If you notice that a and b, so you know, a part of it you have to rewrite. Like this is the you know, you have to keep messing around with this. You know, you write stuff like a plus b equals ab over 20. So you know that like one of ab is divisible by 5, the other one's divisible by 2, or both of them are divisible by 2, one of them is divisible by 4. You get this kind of stuff. Okay. You always be trying lots of things. Here one thing that I found was really helpful was noticing that if both a and b were bigger than 40, the reciprocals would sum to something less than 1 over 20. So one of them has to actually be less than 40. So we can, let's say, assume a is less than 40. Okay, and we know that 40 works. We also know it has to be bigger than 20, because if it's equal to 20, then the other one's going to make it go over 1 and 20. Okay. So this gives you some confidence, because at worst case scenarios, you have 20 cases to try. Okay, or 19 or whatever it is. And so if you didn't have a good way of really finding it straight away, you could just go through all the cases. Another thing you notice is the closer 1 over a is closer to 1 on 20, sort of the bigger b has to be, because the difference is small. Alright, so you're more likely to try stuff close to 20 than you are close to 40. So if you try a equals 21, say, you'll get b equals 420. And so the sum will be 441, and that's going to be a good guess for the right answer if you didn't have any extra time to make sure of it. Okay, so even if you try like 222 or 23 and keep going, you'll see that the b value drops dramatically. So this is the only one that's going to have a sum over 400, and therefore it's going to be the largest. So I skip to question 7 because it looks standard. Yeah, so I'd imagine from people's experience, they'd have to try some. So look, so there's a code, is a sequence of zeros and ones that have no three consecutive, no blocks of 3 zeros. how many 11-digit codes are there? So you do something like this. Okay, so it's good to note that 11 is not very special. It's just something that's big enough to be inconvenient. There's no reason 11 is really related to the 3. What we could do, and what I think basically everyone will do when they start this problem, even if they have a good way of doing it in the end, is to see how many 1 digits. So like, let's maybe call the C1 the number of 1-digit codes. Okay, there's clearly 2. You could try C2. There's 4. C3. Now this is the only time it gets tricky, because you have to subtract the 0, 0, 0 code. So you get 8 minus 1 equals 7. C4. You go to minus the 4 length, 4 zeros, and you go to minus 3 zeros. Either 0, 0, 0, 1 or 1, 0, 0, 0. So you get 16 minus 1 minus 2. So even with 5 it starts to get a bit tricky. And I even made a little bit of a mistake here when I did it. So this is 13. So 5. Okay, so it's 32 if there was no restrictions. Minus 1 for the 5 zeros. Minus 2, lots of 4 zeros. And then, now when you're minusing the 3 zeros, it gets a bit tricky, because so you know, the zeros could be 1 and the 3 zeros in the middle. But when it's not in the middle, it could be like 0, 0, 0, 1, but the other one could be a 0 or a 1. Okay, so there's 2 cases when they're not in the middle for each of the ones that's starting with 3 or ending in 3 zeros. So it's minus 5, I think, yeah. Okay, and if you go to 6, something still happens. But when you go to 7, there's a funny way for 3 zeros to occur. 6 zeros could occur in 2 blocks. Okay, so this pattern is not really going to hold very easily. What is that? 8, 24. But what you do notice, okay, and this is actually a kind of a standard thing, and I noticed this very quickly because it is. You can get some kind of recurrence. Okay, so this is like going with lessons of induction.